So welcome back everyone. I hope you all are good, and I hope you would have seen the last 5 lectures. Then you have come for the sixth lecture because a lot of things we have covered in the earlier part. So if you have a clarity, then things will be a little easy to understand what we're taking up front now. So the next topic that we have in front of us is the trigonometric form or the polar form, okay, or we also call it as like the parametric form. So think like this, that uh, let me take a rough place. Think like this. Okay, suppose there is a line. Okay, and let's say there is a point here. Let's say this point is given h comma k. Okay, and let's say tan theta. You know tan theta. Now any point on this line, any point on this line, any point coordinates on this line can be figured out with the help of this distance and this theta. You can ask like how. So think like this, from this point there are only two possibilities, isn't it? Suppose I'm telling you, think you are standing at a place over here, you're standing at this place. Now can you tell me how many points are there which is at a distance of 2 units on this line? So you'll give only two, either 2 units on this side or 2 units on this side. Means if you change 2 units to 3 units, how many points you will get? Again, two answers only you will get, isn't it? So based on the difference, based on the distance, what you will get? You will get 2 points, one on the upside and other one on the downside. But suppose for the distance also, if I give a term algebraic distance, means if it is in this direction you say plus, and if it is in this direction you say minus. So when I ask you, tell me a point which is at a distance of minus 3 units, how many answers will come? There will be exactly one answer. And which direction? It will be somewhat over here. Can you get this? Tell me a point which is at a distance of 2.5. So which direction? Obviously this direction. Where is the point? The point is over here. Why I'm talking all about this is that I want you to understand that if a point is given and the algebraic distance is given, means the sign also will contain a plus or minus sign, then it will uniquely determine a point on a line. Can you get this? Okay. If not, one more example. Suppose you think like you are standing here, okay? You consider your right side is plus and left hand side is minus. One of your friend, let's say Mohan, is standing here, and let's say Shyam is standing here. So if I ask you, you tell me, let's say this 2 units and this is 3 units, how will you represent his distance? You will say he is at plus 2, isn't it? And how will you represent this distance? This is at minus 3. So if you change the different values, different positions will come, isn't it? So for different r values, you will get different points. So all these points on this straight line can be represented with the help of r. Is it okay? So take a point A, okay, and the slope of the line is known to us, okay. So we want to figure out what is the coordinate of B. What is the coordinate of any point B on this line? So think like this, B x coordinate we want to find. So can we say B x coordinate is this much? Isn't it? The distance from the y-axis. In that, this much length and this much length, there are two parts. This length is what? This length is h, yh, because on a vertical line x coordinate remains the same, isn't it? So here x coordinate is going to be what? It is going to be h. So that's the reason this distance is h. What is this distance? So imagine we have taken r distance on the line. So if this angle is theta, this angle also is going to be theta by corresponding angle. So this length by trigonometry is how much? R cos theta. So what is the x coordinate of B? It is going to be h plus r cos theta. Is it okay? What about y? Same logic. Y is this much, isn't it? In that there are two components, this component and this component. What is this component? This is k. Why? Because on a horizontal, if you take this length, right, on a horizontal line, y coordinate remains constant, isn't it? So this length is going to be k. And what is this length? What is this length? It is going to be r sine theta. So what is the y coordinate? Y coordinate is going to be k plus r sine theta. Is it okay? So any point B can be taken as what? H plus r cos theta or k plus r sine theta. Now as I have told you, r can be plus or minus both, isn't it? Because if it come in the other direction, it will become minus. So what we are telling, that any point B on this line can be given as h plus r cos theta and k plus r sin theta. What is h and k? H and k is a given point. What is r? R is the algebraic distance. And what is theta? Theta is the angle of inclination. So first question, like in the question, nobody will give you angle of inclination, isn't it? What they will give? They will give the line equation. So you can find tan theta. And from the tan theta, you can figure out what is sin theta and what is cos theta. But what is theta? Theta is angle of inclination. And angle of inclination lies in first and second quadrant, isn't it? So sin theta is always positive in first and second quadrant. Okay. So now what are the conclusions we are drawing is that as theta belongs to 0 to pi, your sin theta is going to be always positive. Okay. And cos theta will be positive or negative, depends on slope. Okay. If slope is positive, then cos theta will be positive. If slope is negative, cos theta is going to be negative. What about r? So r is algebraic distance from the base point A. It will be positive if the resulting point is above, and it is going to be negative if the resulting point is below. Okay. To give a better clarity, you see this setup. See, AB distance is given as 39. And you can clearly see the point B is what? Downward. It means what? This R value is going to be what? Minus 39. It is going to be minus 39. What is tan theta? So tan theta, if you try to find from here, it is minus coefficient of x divided by coefficient of y. Okay. So you make a triangle without sign. Tan theta, this is 5, this is 12. So this is obviously going to be what? 13. What is sin theta? Sin theta is always positive, so it is going to be 5 by 13. What is cos theta? So since your slope is negative, cos has to be negative. So cos theta is how much? Minus 12 by 13. So what is your coordinate? Your coordinate is h. H is what? H is minus 1. And k is what? 1. So coordinates will be given as h plus r value, which is minus 39, into cos theta, which is minus 12 by 13. And what is y coordinate? K plus r, which is again minus 39, into sin theta, which is 5 by 13. So when you try to simplify this, what you are getting? 13 will cancel 3 times. Minus into minus will be plus. So we got 35. And here if you do 315, so we got how much? Minus 14. And from the position of B also you can realize, right, that its x coordinate should increase because it is on the right side, and its y coordinate should be decreased, and it should be even negative because it is below the x axis. So from the answer also the same thing is coming, isn't it? Okay. Next part. Okay. One more thing is, not in this chapter, but like when we'll go into circle, parabola and all, you will see like a lot of places we'll use parametric coordinates. Okay. Y and also that we will see it there. So suppose why we have given this line equation also as a parametric form, because if you take any point on the line, so let's say if you take any general point x on this line, and let's say x1 y1 is given point, so this x comma y can be given as what? X1 plus r cos theta and y1 plus r sin theta. So when we compare the x coordinates, what we can write? X minus x1 by cos theta is equal to r, and which is also equal to y minus y1 by sin theta. So this form is also called as the parametric form of a straight line. It is also called as parametric form of a straight line. X minus x1 by cos theta, which is equal to y minus y1 by sin theta, is equal to r. Okay. Now any general point on this line, ax plus by plus c, can be taken as what? You take x coordinate as alpha. So what is y coordinate? You find y in terms of a, b, c and alpha. So what will you get? By is equal to minus a alpha minus c. So what is y value? It is minus a alpha minus c by b. So that's what any coordinates can be taken in that shape. Okay. Basically you can take alpha and beta also, but only thing is there two variables will be there. So suppose if you want to deal with less number of variables, we are expressing beta in terms of alpha. Okay. It's same thing, something like this. Suppose the line equation is written y is equal to x square. So if I take x, I can take the coordinates as alpha and beta, isn't it? But I can also take beta is equal to alpha square, because when you substitute here, you'll get beta is equal to alpha square. So we can